Hey everybody, Dr. A here, and in this video we're going to be providing some background information on what is known as the further simplification of force and couple systems, referencing the Hibbler statics textbook. Now, this is very related to another couple of videos we have regarding developing an equivalent system when having a force couple system given to us. So the difference is before in our other videos, we kind of reimagined an equivalent system and recalculated an equivalent system of having a resultant couple moment and a resultant force at a specific point. In this background video and the accompanying examples of this particular section, we're going to go a little step further and we're going to find where the location of the resultant force could be located from measured from a distance away from a specified point. So in this particular type of equivalent system analysis, we're not really going to have a resultant moment that we're going to utilize anymore. We're still going to have a resultant force, but it's going to be located at a specific distance away from a reference point. So without further ado, let's go ahead and get started. But don't forget to hit like and subscribe and be on the lookout for other content like this.
In this video, we're getting into the next section, section 4.8, which pretty much goes hand in hand with section 4.7, and it's on further simplification of a force and couple system. So basically, in this case, we're saying that we can further simplify a system if we have the following conditions. Okay, so these conditions basically state if we have a concurrent force system. Okay, if we have a concurrent force system, which a concurrent force system states that lines of action of all forces intersect at a common point. Therefore, there is no moment about this point. So that's kind of like the particle equilibrium problems we've already dealt with. Those are called concurrent force systems. So for example, like if we have, let's say we have a two-dimensional body here, and we have an F1, an F2, and an F3 here. So if you look at this, the way I drew this, the lines of action of all of these forces intersect at this common point right here. So this is called a concurrent force system. Okay. The other possible case, we said following conditions. So I'm make another bullet point here. If we have a coplanar force system, okay, and in this case, the lines of action of all forces lie in the same plane, which that's actually, we've dealt with that already. That's just a 2D system, right? All the forces are in the same plane, okay? So we would say, thus, the sum of the forces equals a resultant force. And all moments are perpendicular to this plane. So that makes sense. So that would be like, again, if we have a body, this is a two-dimensional body, and we have an F1 here, and maybe we have an F2 here. These are in the same 2D plane. And let's say we have a moment right here, call it M, all right? And the moment axis is right here coming out of the screen, in and out of the screen. Well, if you have a moment that's in a perpendicular, that's perpendicular to a plane that you're interested in, that just means that this moment is rotating about an axis that's perpendicular to the plane you're working in, which is what I've designated here as this red dot, okay? And then the last condition that we may find ourselves in where we can further reduce a force and couple system is a what we call a parallel force system. If we have a parallel force system. Now, what is that? In this case, this is commonly seen when all forces are parallel to the z-axis. Okay, thus the resultant force is also parallel to the z-axis. Okay, so in a case like this, I'm going to draw this in 3 dimension. Let's say that we have a plate or maybe a foundation of some sort, and this is the z-axis, and maybe this is the y-axis, and this is the x-axis. And then let's say that we have all of these forces here that are all parallel to the z-axis in 3 dimensions. So we can perform a lot of nice simplifications and kind of consolidations of the forces acting in this kind of system. So these are just meant to give you some kind of illustrations. And again, if you take a look at section 4.8 in the text, you're going to find some more explanation and really better figures than what I am able to draw for you here. So I would say read section 4.8. You should always be reading the book anyway. And we'll do some examples of this in the coming couple of videos.